We have this inclined plane and there is a boat. So the mass of the boat is 400 kg. So that is the mass of the boat, and it is at rest on a slipway. It's held by a rope, and that's going to be some sort of a tension. So we can consider this to be some sort of a tension. The boat is modeled as a particle, and it's on a rough surface, 15 degree, and the coefficient of friction is given mu equals to 0.2, and light extensible string. The boat is in equilibrium at the point of slipping down. If it is at the point of slipping down, that means friction is going to be in the opposite direction. So you have to calculate the tension in the rope. Okay, so let's first of all write down all of the forces that we can possibly have. So the first one is the weight. So this is going to be 400 g Newton. So this is going to have two components. One is going to be mg, that means 400 g sine 15 degree, and the other one is going to be 400 g cos 15 degree. So these are the two components of the weight, and now we know there is going to be reaction force, normal reaction force R, and so that's the idea. So we have this information given. Now this is tension T. So let me call this tension T. Now since it is at the point of slipping down, so if it is at the point of slipping down, that means the friction is going to be opposite to that. So friction is going to be here, mu R. Mu is 0.2 R. Now since there are no other components other than normal to the plane R and 400 g cos 15, so we can basically say that R is going to be equals to 400 g cos 15 because there is no other component and they are in equilibrium. And now along the plane, so along the plane the force that is trying to pull it down is 400 g sine 15 degree, and the force that is trying to pull it up is, one is tension T and the other is 0.2 R, and R is 400 g cos 15 degree. So from here we can calculate the value of the tension. It is going to be 400 g sine 15 degree minus 0.2 into 400, that is going to be 80 g cos 15 degree, and that is going to give us the value of the tension. So tension equals to, so this is going to be 258 Newton. So now the next question, question number B. So question number B is, the boat is 50 meter away from the bottom. So it is traveling a distance of 50 meter. If it falls to the bottom, it will travel a distance of 50 meter. The rope is detached from the boat and the boat is sliding down. So calculate the time taken for the boat to go to the bottom. So one of the things that we have to see is, now we have to see what the acceleration is. So if the object is moving in this direction, so now the forward force that we have is 400 g sine 15, and there is no tension holding it, so the only thing it has is friction. So friction is going to be mu R. Now R can change, but in this particular math R is not going to change because there has no component been added or removed, so the value of R is going to be the same. So this is going to be mu R. So that means we can say that the net force that we have over here, that is going to be give us the mass into acceleration. So net force is 400 g sine 15 minus mu R. So 400 g sine 15 we already know, this is 1014.6 minus mu R. Mu is 0.2, and this is, so the net force is basically the same as we just found. So the net force is 258 Newton, and we know net force equals to mass into acceleration. So mass is 400 kg and the acceleration is unknown, so therefore we can just divide this with 400 and we can find the acceleration. So this is 258. 0.645 meter per second squared. So this is the acceleration. So we know that if an object starts from rest and then it travels a distance, so it travels a distance of 50 meter, initial velocity is 0 since it starts from rest. We know that it is accelerating at a rate of 0.645 meter per second squared. The only thing that we need to find is the time taken. So we can use that x equals to ut plus half at squared. Since initial velocity is 0, so plus half a is 0.645 t squared and displacement is 50. 2 into 50 is 100. 100 divided by 0.645 equals to t squared. Therefore, t equals to square root of 100 divided by 0.645, and that is 12.5 seconds.